Okay, now we're going to continue Unit 6 to Part 2. Efficiency. Efficiency is an indicator of the equipment efficiency and can be calculated as follows. So you have your efficiency equal to theoretical production time divided by actual production time. So if an equipment is running for 6 hours, the actual production time is equal to 6 hours. So how many units should we have produced during this time is what we want to calculate. So the theoretical answer 6.0 hours time theoretical hourly production rate. Okay, so if we assume the theoretical cycle time is 0.0125 hours per unit, theoretical hourly production would be equal to 80 units. So 6.0 hour times 80 units per hour is going to give you 480 units. So if you forget about how to get 80 units from your theoretical cycle time, so here again, hours per unit. Okay, so we're going to flip it. It's trying to tell you in order to produce 1 unit, we're going to spend 0.0125. So you flip the ratio in order for you to be able to get units in an hour. Okay, so 1 hour, you will divide 1 divided by 0.0125. So that way you can put the unit above the dividing line and then hours under the line. Okay, therefore you will get units per hours. And we call that flip the ratio. So instead of hours is to unit, we're flipping the ratio, you become units is to hours. So in that case, we're going to divide 1 by 0.0125 is going to give you 80. Okay, that's how we get it. Now you will multiply with your 6.0 hour, and this is your equipment running time, or you can call like the actual production time. Okay, when you multiply that too, we will get 480 units. Hour is going to cancel out, okay, because this is above the line, that's under the line of your division line. So here I'm going to show you, so 1 divided by 0 points difficult to write, 0.0125, okay, so that's how you do it. So calculate that in your calculator and you will definitely get 80 units. Okay, here what I'm trying to tell you is your hour, okay, is time with your units. So here when it's hard to write on the screen. Okay, anyway, so units, okay, per hour. So you multiply 80 and 60, so you definitely get 480. So this unit, we get, okay, a new unit because this hour is going to cancel out, okay? So this two cancel out, so you get 480 units. So make sure you review all of that high school calculation, okay? Those are just algebra. Okay, so what if any 400 units were produced? So the theoretical production time for 400 units, so that's what we want. We already know we spend 0.0125 hour per unit. Now we have 400 units, so units and units will be cancelled out. So you will get 5.0 hours, okay? So that is the hours needed for 400 units production. So the same thing here, you have hour, and then you have your unit here. So that's, and then you're gonna multiply that with 400. is unit, okay? So unit. So this is gonna cancel off, so you're gonna left with hour. Okay, that's how we get the hour here. Okay, so let's move on. So therefore, efficiency 5.0 hour theoretical production time divided by 6.0 hour production time. So this is your 5 hour from 400 units production, and this is your 6.0 hour, and that is your actual production time. Okay, so when you divide that, you can be able to calculate the efficiency. You will get in decimal. So 5 divided by 6 is going to give you 0.833, and you're going to turn that into percent. Okay, so you'll get 83.3%. The same thing, so 0.833. So if you want to turn that into percent, you want to look at the decimal, okay, place right there. So here is 1, that's your 10, okay, that's your 1, and then your decimal will come here. So you get 83, and then your decimal come right there, and then your 3, okay. So you should be able to read this back and forth. If you see 83.3%, that is 0.833. Okay, if you see 0.833, you already know you have to cut it right after the second decimal place, and you put your decimal right there. So this decimal is going to jump to the back two, okay? 2 places. So make sure you get this forward and backward. Okay, so that's for efficiency. Quality. The quality is the ratio of the acceptable parts to the total parts produced. So that's how we calculate quality. It's just a ratio. Suppose that during the production run, a total of 400 units were produced, of which 50 were rejected for various reasons like scrap or rework. Okay, rejection is one of them, or defects. The numbers of accepted parts is going to be total parts produced minus rejected parts. Total parts here in your question, it's given to you 400 units minus rejected right here. Okay, for scrap and rework is 50. So 400 less 50 is going to give you 350 accepted parts. Quality in mathematical expression. Outside you're going to say quality is looking good or shining or something, okay, whatever you say out. But mathematically we're looking at the acceptable parts, okay, to the total production parts. So out of everything that we produce, how many of them are accepted to go into the market? And that is called quality in the manufacturing industry. Okay, so 350 divided by 400 is going to give you 0.875. Turn that into percentage, so you get 87.5. I'm going to review again. 0.875. Every time you see, you're going to move one place, second place, you're going to cut that out. Okay, and that is your 87.5%. Funny to write. Anyway, you got the idea how to do it. And you have to go back and then forward, okay? Okay, based on the previous discussion and calculations, our OEE, we can calculate this way. So the review of your OEE, Your overall equipment effectiveness is your OEE. Every time you see this, remember that is your overall equipment effectiveness. And we will calculate by multiplying three factors: your availability, efficiency, and quality. Okay. So these units come from your previous examples. So in the availability, we get 92.3%, efficiency, we get 83.3%, and quality, okay, we get 87.5%. So now we're gonna calculate OEE by multiplying all of that, and you will get 67.3%. So OEE is a measure of overall equipment efficiency. So a higher value, this percentage, is going to tell you an overall better condition, okay, than a lower value. If you have like 30%, that's not really good equipment efficiency. If you have really high percentage, then that's a better condition for your equipment. So when you look at your overall equipment efficiency, this is just figure 6.1. It's showing you the OEE calculation formula and its components here. It needs a component here. Its component, okay? And when you take a look at this first two part, you're going to see a little bit better. So OEE is multiplication of your three factors: availability, performance, and quality. Availability reflected in operating time loss. So it's nothing but your equipment failure loss, okay, all known stoppages, example, process setup adjustment losses, startup losses. So your shift, your lunch, your repair, and your weekend. So that's how we consider for availability. Then we think about performance, so that's reflected in net operating time loss. So we look at idling and minor stoppages, catches and non-stops, speed loss, engineering design speed versus actual speed. Okay, every time you see versus, that means we are studying these two factors, okay, on y-axis and x-axis. So we're seeing the relationship of that two and can be able to calculate the speed loss out of it, which we consider this 1 and 2 for our net operating time loss. Okay, for quality, it's reflected in value operating time loss. So we look at quality defects, rework, okay, required. So all of that, defects and rework required, we look at that to consider the value operating time loss. So your OEE is again availability times performance times quality. This is just a little note telling you the TPM and record keeping, if they improve, performance efficiency is going to improve, but at the expense of availability. Okay, this is just showing you the area of team and group leader concern for OEE, okay, calculation steps. So here, overall equipment effectiveness, we get 79.67 in this example because your availability is calculated to be 93.2. Performance, okay, is calculated 87.5 and quality is 97.7. So we get about 80% overall. So how do we calculate that? Is you look at your working hours, loading time, operating time, okay, net operating time, and actual operating time. And these little ones are the losses, okay? So here you have minus 9.8. It's going to come because of the defects and rework, performance again. All these factors that we look at in the previous picture diagram, okay, is going to be accounted for all this loss, okay? And then you will calculate, and these losses are the concerns of these area team and group leader, and they always pay attention for these losses due to these considerations. And then when you calculate it, okay, and you're going to get availability. That's just an example given you with some numbers, okay? And this is how you calculate for each availability, performance, and quality. So if you have a loss, you're going to minus the defect units from the process units and then divide it by your process units times 100. For performance, okay, the same thing. You have a standard cycle time and then you have units made divided by your operating time. It's going to give you your performance. Availability, your load time minus downtime divided by loading time is going to give you times 100, going to give you your availability. So make sure you get 1, 2, and 3 calculations how to do it in order for you to be able to calculate the OEE. Okay, I'll ask you and you should be able to calculate that. The same thing, we're looking at the losses, okay, and these are the reason for these losses. So they're just showing you your area management concern and then your team and group leader concern, and those are our major losses in the facility. Quality. So along with the assessment of current equipment condition, the current skill levels of the operators also must be determined. So an inventory of current operators' skills can be obtained with the aid of the Human Resource Department and by reviewing personal files. It's just telling you that not only the equipment condition, we are actually looking at the skill level, okay, of the operators, and we determine that skill level. And we use human resources. We also review their personal files so that we can be able to have an inventory of the current operator skills. Okay, so when we assess quality, sometimes we do personal interviews. So it's just kind of like adding a personal touch to make each operator realize that they're a special part, okay, of the TPM team and process, because they really are special, because without them you can't be able to do any kind of operation. So since training is one of the most important factors in implementing TPM, so the skills, inventory data can help determine the extent, okay, type, and amount of training required to transfer some of the maintenance activities to the operators and create more self-reliance among the operating personnel. So just trying to tell you that sometimes we gotta talk to them directly, okay, and then make sure that they understand they're important in the process or in this TPM strategy. So the heart of the TPM process is nothing but the transfer of ownership, the transfer of responsibility, okay, for the basic equipment maintenance activities to trained, well-prepared operators. So the responsibilities include maintaining equipment cleanliness, cleaning, and then developing lubricant standards, lubricating your system need lubricants, and following the inspection procedures, and taking the initiative and workstation organization and continuous process equipment. So what it's really telling you is that we have to empower the operators so that they can be able to take care of their part of the system by cleaning, by developing the lubrication standards, by following the inspection procedures, by taking the initiative and workstation organization, and by doing the continuous process improvements. So cleaning, yay, the purpose of the initial cleaning is not to overhaul the equipment. We don't want that. What we want to do is to develop the understanding of the machine. So you clean the machine, and doing that is trying to understand the machine. You have to know your machine inside out. So it's just an ongoing task, okay, to keep the equipment like a new in a like new condition. So identify the sources of such contaminants is going to give clues to some simple equipment design changes or modifications, like curtains or guards, okay, that are used to divert and collect the contaminants and minimize the adverse effect on the equipment. So make sure you do cleaning for all of your station and also your equipment. Developing lubrication standards. So these standards are based on manufacturer recommendations and requirements and lubrication procedures previously performed by the maintenance personnel. So that's how we develop the lubrication standards. So develop checklists, pictorial images so important to facilitate communication. Drawings and pictures can be used to easily identify and locate the lubrication points. Okay, sometimes it's really difficult to put your hand into the machine, so that way this is just a cartoon, okay, not realistic. Sometimes we have to use a different shape, okay, of lubricating tools. Some of them have like a very long and narrow pipes, okay, so you can reach to the lubrication points inside of the machine. The lubrication standards for all equipment should document type, frequency, and amount of lubricant to be used. So that's how we form the lubrication standards. So here you can take a look at example on a figure 6.4. So you have some pictures right there pointed out what they are. If you take a look at an exaggerated picture, you can see that's your equipment maintenance standards. And here is your pictorial illustration. Okay, it's just showing you your section, equipment name, and issue ID. Okay. And here we go, that is at your cycle at 3 months, 6, a year. Okay. And then it's pointing up this 2 points, which is your X point. Okay. And then you're going to check your 2 conveyor lubricators for east and west rollers. So that's what your lubrication point is. And that's how we form the equipment standards for lubricants. Okay, so nobody knows the feel of your equipment better than the operator. So it is his or her machine. So they know the machine very well. So general inspection should be part of the process when the operator performs routine cleaning and lubrication procedures. So this type of inspection is just a daily inspection, okay, done by the operator. It's not your quality control inspection at all. The visual inspection of electrical components and connectors can bring to light any unsafe conditions. So that's what we're trying to find. Your loose and damaged wiring, etc., etc. Okay. TPM provides the opportunity for the operators to review and then modify existing procedures or recommend new preventive and predictive maintenance practices, because they know the machine. Okay, so we listen to them. Inspection. Continue. So operator initiated inspection, okay, should also include training and also a working knowledge of the plant computerized maintenance management system. So we put it into the CMMS, we feed it. So access to CMMS enables the operator to examine and determine the relationship between various maintenance activities and the overall equipment effectiveness. So that provides an excellent opportunity to expand operator involvement in improving and optimizing quality and productivity. This is just generally trying to tell you that whatever, okay, their inspections that should be in training, and also this knowledge that they have gathered from their system got to be recorded in the CMMS. Okay, so that's just nothing but it's another system that we use in the plant. So computerized maintenance management system. Okay, you always find one in the production plant. And this CMMS again is going to help everybody, okay, to examine and determine relationships and etc. etc. And that's nothing, we use them to improve and again optimize the quality and productivity. Manufacturing is nothing but productivity and quality, and we do everything we can to achieve that. Workstation organization. Housekeeping, okay, please clean up. Workstation organization play a very important role, again, in quality and productivity. So principles of safety, motion economy, ergonomics, We're going to consider all of that when we design and organize our workstation. Okay. Continuous process improvement. So factors such as delays due to material shortage, or delay due to excessive setup time, delay due to manufacturing or material handling steps that are necessary, excessive inventory, and a host of other variables have the same adverse effect on the productivity and, of course, efficiency as do equipment breakdowns and failure. Okay, so we don't want delays. We don't want delays at all. So with proper TPM training and implementation, operators can formally and systematically take an active role in analyzing and improving various manufacturing and processing steps. So again, we have to improve the process. We have to analyze the process in order for us to be able to improve that. Okay, so therefore everything that is going to cause us to delay got to be studied. So here are all of the factors listed right here that you have to pay attention, okay, in the processes. So additional industry engineering methodology, okay, of analyzing steps that are required to perform a task to eliminate, reduce, or simplify each step have an important place in TPM and overall performance again improvement. So continuous process improvement, we call that CPI, can and must be used to reduce the setup, to reduce the manufacturing cycle times, reduce and simplify material handling and inspection. Okay, so eliminate or minimize work in process. So that's what we're hitting in order to improve the processes. So this is just a figure 6.5. It's just showing you a partial process chart with steps in a specific task. So this process chart also can be used to determine the root cause of various difficulties, and then we consider methods or procedures to eliminate the root cause of such problems. So here in this chart, these are just a part name, and is your package grid on this example. Your plant is at Shape Tree Grills, recorded by this person RM, and date is that. And here are your symbols, operation, okay. So this is a process chart, so remember chapters. Previous chapters: operation, transport, inspects, delay, and then stores. So we have altogether in this chart 58 steps. Okay? And the distance is about 60 feet. They move around. So step 1 to 5, we exaggerated that part right there. Then here we have operation, transportation, inspection, delay, and shortage. So this is your description of method again. Grasp the retainer, prepare the retainer, place the retainer on the conveyor, grasp the grid bottom, and then place the grid bottom on retainer. So that's your description of your method. So we're breaking down all the way down to your work elements again. So we're using hands here, okay? Distance that they're giving you here only at the conveyor. So that's a 6 feet. And then quantity, okay, it's 1, 2, 3, you can put right there. So right now I'm just going at 1. Okay, so that's it for chapter 6, unit 6, okay? So make sure you study again. Studying is you have to read the handout, read the presentations, listen to the lecture, and then you're going to do that again and again. And make sure you use a paper and a pencil or a pen to practice calculations, okay? We have quiz next week, so make sure you're ready for it this time. I will definitely put up the study guide, which is going to be up this week, so you can study coming weekend for the quiz. Quiz is going to be next Thursday.